This is a video lesson for the worksheet that you'll be getting on April 3rd. It's your first homework worksheet. This is still concept 35. I'm going to work out most of the odd problems in this worksheet to help you get started, but you are required to complete all the other problems. Number 1 says, what is the sum of the measures of the interior angles of an octagon? Please have handy the first worksheet we did on notes, okay, the one with the tables that had all the figures with the number of sides and the sum of the interior angles, because it's going to make some of these problems a lot easier to work with. So what is the sum of the measures of the interior angles of an octagon? So the octagon is in our table. It's the 8-sided figure here, and it's the third column, right? That is the sum of the interior angles, 1080. So number 1 is just information pulled from our table already, and we're done. Number 3 says, what is the measure of each interior angle of a regular hexagon? So we have, use blue here, a regular hexagon. I'm a double underline hexagon. This is a polygon of 5 sides. Not 5, sorry, it's 6 sides. 6 sides. And going from my table here's the hexagon, 6 sides. The sum of the interior angles is 720 degrees. So the question is, what is the measure of each interior angle of a regular hexagon? So then you take 720 degrees and then you divide by how many sides you have, how many angles in the interior you have. That's is based from how many sides you have in the polygon. You have 6 angles in there, so you do 720 divided by 6, and then that's going to give you 120 degrees, and that's the answer. For number 5, it says, what is the sum of the measures of the exterior angles of a decagon? Decagon is a 10-sided polygon, and then we know from our notes there was a theorem, right, a conclusion we made that the sum of the measures of the exterior angles for any polygon is always going to be 360 degrees. That's true for all polygons regardless of the number of sides. Number 7, it says, if the exterior angle of a regular polygon is 22.5 degrees, how many sides does it have? Okay, so the exterior angle is, see, maybe we can write this here. So we have exterior angle is 22.5, and then pulling from our notes from yesterday, this problem is similar to number 7 and 8. Okay, they give us the measure of the exterior angle. We know that they all add up to 360, and we're finding the number of sides. So it's the exact same setup. Okay, and it's, of course, we can assume the same setup because it's a regular polygon. All the angles and sides are congruent. So I have 360 divided by x, the number of sides, is equal to 22.5 degrees. If you solve for x here, you're going to get 22.5x is equal to 360, and if you divide 360 by 22.5, you get 16. So x is equal to 16. This is a 16 gon, okay, or 16-sided polygon, whatever you can fit in a little space. And we're done. Moving on to number 9. It says, if the sum of the measures of the interior angles of a polygon is 1980, how many sides does it have? Okay, so this is the formula, the very first formula. Okay, the sum of the interior angles is equal to the number of sides subtracted by 2 times 180 degrees. So they tell us that the sum of the interior angles is 1980 degrees. How many sides does it have? So they give us S. So you plug in for S and you're solving for N, the number of sides. Okay, as it says here, how many sides does it have? So it's a multi-step equation. You can start by dividing. Let me see, we have PEMDAS, right? So before we can do it or look at anything in the parentheses, we need to isolate it. So divide both sides by 180. You'll get that 1980 divided by 180, you get 11. So 11 is equal to N minus 2. Right here you'll add 2 to both sides and you'll get N is equal to 13. So the number of sides of this polygon is 13, or a 13gon. Let's look at number 13. I'm going to skip 11. I'm going to have you do that one. Number 13, it says find the value of x. So I have this oddly shaped polygon. This is definitely not regular. As you can see that the measure of each angle is different. However, we could still use the properties of the number of sides to figure out what the sum of all the angles are, and then use that to find x. So I have we can count the sides here. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8. So this is an 8 sides, an octagon. Okay, so it's that first formula we have, and S is equal to N minus 2 times 180 is equal to, and we know that this is sorry, the number of sides is N, it's 8, so N 8 minus 2 times 180 degrees, you get 6 times 180, and this is equal to 1080. And if you're handy with your notes, of course this is also in our table. Okay, so the octagon, 8 sides, 1080. So I didn't have to do any of this work. So what I do from here is, we know that all these angles here have to add up to 1080 degrees. Okay, similar idea to our triangle problems we've done in the past. We know 7 out of the 8 angles. Okay, so I can subtract the sum of the 7 given angles to find the measure of the last unknown angle. If you add up these 3 here, let me do this in red. Okay, so if you add up the red angles here, you get 936. So this is 936 degrees. 1080 minus 936, you're going to get 144 degrees. And that's your answer. So that angle there, x, is 144 degrees. When you add them all up, you get 1080. Moving to the next page, let's look at number 15. It says solve for x. We have a quadrilateral. It's a 4-sided figure, 1, 2, 3, 4, and then one of the sides is extended past one of its sides here. Okay, and this exterior angle here that's given is going to prove useful for us because we have a straight line there. Okay, so we can use it to find the red angle in here. Okay, so I have 180 degrees minus 71 degrees, and I get 109 degrees. Okay, so this red angle there is 109 degrees. It says solve for x. We have a quadrilateral. Okay, so I have 4 angles. I can add up all 4 angles, and knowing from my table here, okay, a quadrilateral, the interior angles add up to 360 degrees. So just like we would do with our triangles before, add up the angles, set equal to 180. You're going to add up the 4 angles and set equal to 360 degrees. So I have 10x. I have, or actually, maybe an easier setup. No, yeah, we're going to go ahead and show every step here. So 10x plus 6 plus 13x minus 2 plus 8x minus 1 plus 109 is equal to the sum of the interior angles for a quadrilateral, which is 360 degrees. And again, that comes from my table. Combine like terms. I'm going to underline my x's in blue, and I'm going to underline my constants in, let's use green, here, here, and here. When you combine all of those, you're going to get 31, yeah, 31x, and then plus 112 is equal to 360. Subtract 112 from both sides, and you get 31x is equal to 248. Divide both sides by 31, and then you get x is equal to 8. So then the value of x here in this quadrilateral is 8. Last one I'm going to do here is number 17. It says if the figure below is a regular polygon, solve for x. So again, key detail here is that it's regular polygon, so all the angles are the same, and we can use that idea, okay, to find x. It's a pentagon, it's a 5-sided figure. I can use my table here. Okay, the sum of the interior angles for a pentagon is 540 degrees. So if I add up the 5 angles, okay, I get 540 degrees. I have 9x minus 18. Okay, and it's regular, so all the angles are congruent. I have 5 of the same angle, so I can do 5 times 9x minus 18, because all the angles are the same, 5 angles of those. So, and then it just becomes distributive, right? So I get 45x 45x minus 90 is equal to 540. I add 90 to both sides, and I get 45x is equal to 630. Then in your calculators, you'll do 630 divided by 45, and you'll get that x is equal to 14. Okay, so the value of x inside this pentagon is 14. And that is the last problem I'm doing in this worksheet. Again, you are required to do all the others. Okay, please use your notes from yesterday and the ones in this video to be able to complete all your assignments.